Today, we'd like to talk about our newest integration to the API, which is the climate projection data. So the general structure of the presentation or of the webinar will be as follows. First of all, I will do a presentation about the climate data, what kind of climate data we do ingest, and which scenarios we chose and why. Then this is followed by a climate data demo, so you can see the climate data live in the API. And after that, there will be a Q&A session. So with that being said, you can ask all the kinds of questions throughout the presentation as well. And for that, just take your mouse, hover over the screen, and then you will see a little Q&A button. And on this Q&A button, you just click on it, and then you can ask a question. And after the demo has finished, I will address all the questions. I can see them coming in as well. So with that being said, I think let's just get started with the climate data presentation. This is the day I've been looking forward to for the past several years. Every once in a while, a revolutionary product comes along. And we at Meteomatics, we are very delighted and very fortunate to have been working on multiple of these revolutionary products. The first revolutionary product was the Weather API, where we ingest model data, station data, lightning data, all sorts of observational data into one API with a resolution down to 90 meters. The second revolutionary product were the Meteor drones. At the moment, we built the Meteor drone in its 4th generation, and it can fly up to 7 kilometers height, which means it is the highest commercial flight in the world. And today, I would like to introduce a new revolutionary product to you. So when we go to the beginning of the weather data, it starts in 1979 with historical weather data. So soon we will be able to provide historical weather data down to 1950. But for now, we go a bit more into the future. So today, or up to the current date, we provide current weather data, for example, lightning data, station data, all kinds of weather observations, satellite data. And up to 3 to 2 hours in advance, we provide nowcasting data. Up to 3 days in advance, there are regional models. Up to 7 to 10 days, this is the usual range of global models. Model ensembles go out to approximately 16 days, and long-range ensembles go out to 46 days. And up to 7 months, there have been seasonal data. So 7 months is already a very long time frame to forecast weather. But now and today, we are very delighted to announce that we will be able to provide climate data up to 100 years into the future. With that being said, we would like to explain why we are using these kinds of climate data, why we do ingest the climate data into the API. So the traditional way of obtaining climate data into the API was designed purely for the climate community, and there's pretty much nothing wrong about it. However, for climate data to be obtained, you need to undertake several steps. So for example, first of all, you need to find a data portal where you can find the climate data, which is not a very easy task to do. And particularly if you're not really into climate, you need to click through the models, you need to find out which models provide which scenarios. You need to understand the abbreviations. So for example, if you have a look over here, you see MRI ESM 2.0, and it's not really straightforward to understand how or what that really means. So the fourth step would be to say, okay, I would like to have a certain resolution, say 100 kilometers, 200, 500 kilometers, and a temporal resolution as well. And you need to select an experiment ID, the interval, and the variable you would like to download. Again, this is designed purely for the climate community, but these are all the steps you need to undertake, you need to go through. And these steps take a certain amount of time. So we came up with a different way of obtaining the climate data, a much more succinct and easier way to do it, the Meteomatics way. The only thing you have to do in the Meteomatics way of obtaining the climate data is to take the current API query, or if you're not a customer, we are very happy to sit down with you and give you some examples of the API query, or you look them up on our documentation page. And all you need to do is change the valid date time string over here to a date in the future, which is greater than 7 months. So just as a repetition, or just as a reminder, the general structure of our API is api.meteomatics.com, the valid datetime string I was just been referring to, and the parameters, which can be, for example, the temperature, the precipitation, the radiation, whatever you would like to query, the locations. This can be a single point, a single location, or just a grid. It really depends on what you are after. And the format, which can be CSV, XML, or JSON, or like a PNG file, but I will come back to that later on in the live demo. So in this example over here, I selected the temperature for the 1st of July in 2050. And over here, you already see the 5 different climate scenarios. And this is something optional that you can select whether you would like a scenario which is maybe not that dramatic, which would be SSP1. But there are other scenarios, and I will explain that in the next couple of slides as well. SSP5, which is a bit more dramatic. The climate data we make available in the API consist of 5 different climate scenarios. These are called SSPs, the Shared Socio-Economic Pathways. These are available on a global coverage, and they are also recognized by the IPCC, which is the Intergovernmental Panel on Climate Change. And the next report, which is the 6th assessment report, this one comes out in 2022. And these 5 scenarios are part of that. So the scenarios we are publishing in the API will be used by the IPCC for their next report. At the moment, we are focusing on atmospheric parameters such as the temperature, precipitation, radiation, and wind speed. And the data is downscaled to 90 meters, considering the topography. Again, all scenarios are available up to the year of 2100, which means combined the weather data and the climate data, we have over 120 years of data available with one API call. As you might know already, we derive some parameters on our own, and we do that for the climate scenarios as well. At the moment, we have around 40 derived parameters, and these include the wind direction, the wind gusts, the height of the planetary boundary layer, and several maximum, minimum, mean parameters with different units and timescales. For example, if you would like to query the radiation for, say, 3 hours, you can do that with one parameter, or with over 6 hours, you can do that with another parameter as well. The data source, so the data originates from the Meteorological Research Institute in Japan, which is what MRI stands for. And the Earth System Model, ESM 2.0, is the name of the model. And this is governed by the CMIP6 consortium, which is a climate consortium that provides a common framework for similar climate simulations to ensure comparability. Let's talk a bit about more the motivation behind integrating the climate data into the API. So the change in weather over a course of 30 years is referred to as climate. And the change in weather is something that affects every one of us. Doesn't really matter where you come from, where you live. It really affects everyone. And in meteorology, what we do to describe changes is to calculate anomalies. That means you calculate a mean over a certain time period and another mean over another time period, and then you subtract them from each other, which means in the end you come up with anomalies, and this is what I plotted here. So I took the last 20 years of reanalysis data and the last 30 years of reanalysis data of the 2-meter temperature in degrees Celsius over Europe and calculated an anomaly, which means Red colors indicate a warming, blue colors indicate a cool down. And what we see here is that over huge parts of Europe that the temperature has been risen by about 0.5 degree, which is quite remarkable. So, and this gives already a hint of, okay, there is something that changes in the future, and the climate scenarios provide a kind of an outlook and kind of so you get an appreciation of how the weather may change or could change. It's not definitive to say, okay, this is the future and this will happen. This is just these are just thought experiments. So. And now we come back to the pathways or to the scenarios a bit more. So again, these are called shared socioeconomic pathways, and these are on an axis of challenges for mitigation and challenges for adaptation. So a scenario, for example, like SSP1, which is all about sustainability, has low changes for adaptation and low challenges for mitigation. On the other hand, SSP3 is a scenario that has high challenges both for mitigation and adaptation. And all these scenarios are driven by different CO2 emissions, for example. So when you have a look at SSP1, it has a lower CO2 emission in the future than SSP5, for example. And this is also reflected in the global mean temperature. So up to the year of 2050, the warming is evident in all the scenarios, but this is not a huge spread. But if you go further into the future, so for example, up to 2100, there's a huge gap or a huge spread in the forecasted or in the modeled temperature. So let's talk about the SSPs in detail individually. So SSP1, again, is a scenario that is all about sustainability. The world shifts to a more sustainable path, and like the growth in economy includes the human well-being. In general, there's a low material consumption and there are low requirements for both resources and energy. SSP2 is a scenario that has a bit of everything, which means it's called the middle of the road. So in a sense, social, economic, and technological trends do not really shift markedly from historical patterns. And when countries or societies try to achieve sustainable development goals, the progress in that is pretty slow. The population growth is pretty moderate, and the inequalities in income, they only slowly improve or just persist over time. SSP3, like previously mentioned, is a rocky road and is a bit about research and nationalism. There are a lot of insecurities and concerns about competitiveness, and the countries pretty much focus on their own internal issues. So for example, they try to achieve energy and food security goals, and the development in the economy is comparably slow, and the consumption is very material intensive. And one thing we see nowadays is that, or nowadays as well, is that the population growth is low in industrialized countries and high in developing countries. SSP4 is about a divided road and all about inequality. So this means there are increasing disparities in economic opportunity and political power, and there are unequal investments in human capital. So there, on the other hand, there's a high development in the technology within the high-tech economy. The energy sector experiences diversification, so there are other energy resources explored. SSP5 is really about taking the highway, and it's about a fossil fuel development, which means there are strong investments in health and education, in institutions, and it's with the overall objective to enhance the human and social capital. One aspect that characterizes SSP5 as well is the rapid growth of the global economy and the population. With all that being said, again, these scenarios are just thought experiments. It's an indication of what may happen in the future and how that affects temperature, radiation, for example, I will show during a live demo. So in general, if there are any inquiries about our climate data, I'm very happy to answer all the questions later on after the live demo. And please also feel free to reach out to the sales team with the email addresses shown in here. With that being said, let's go over to the demo so I can show you how the climate data works in our API. I just switched off the video so we can better see the demo which will take place right now. Let me just switch the screen right here. So in general, when you would like to get access to the API, and many of you probably know that already, you go to api.meteomatics.com and then navigate to the Getting Started page. So on the Getting Started page, you again see the link or the general structure of the API. So it's api.meteomatics.com, the valid date time string, parameters, the locations, and the format. And today I would like to take the opportunity and build a query from scratch that will include the climate data. So let's open a new tab over here and click on api.meteomatics.com. And then let's start from the 1st of January of 2020 at 0Z. And let's go just to 2100 as well, the 1st of January. And we choose a granularity of, say, 1 month of data. For the parameter, we choose the 2-meter temperature in degrees Celsius. And the location, this can be anywhere right now. So this is just an example for now. And then the format for now will be HTML. And if we click on that link, we will be asked for our credentials. Just hit OK. And it just takes us a few seconds and the API will display all the climate data included up to the year of 2100. So again, we start here on the 1st of January 2020, and we see visual representation of the temperature up to the year of 2100. So in the lower left corner, you see 2 columns, the valid date, which again starts from the 1st of January 2020, and the temperature itself at 2 meters height over the ground level, which is around 2.5 degrees. So the next step is to explore a couple of formats. So for example, we don't only have HTML, which gives you again a very quick representation of the temperature, but we can also choose a CSV format. So just change it to a CSV, and the API will transform the request into a CSV format. We can do that also with a JSON format, for example. By just typing JSON. So if we type JSON, then the format is transferred to JSON, or finally we can choose XML for this kind of query, and you see again the date and the associated value. So we are not only able to select different data formats, but we can also choose another model source. So for example, we will select another scenario in that case. And how you do that is by typing MRI ESM2, which is the name of the model. And then we choose SSP 5F5, which is the most extreme scenario in our API. And then you see a rise in the temperature because it's a more extreme scenario. So we can also have a look at how the data is visualized on a map. For this to happen, we just choose another valid datetime string. So we just select a single time, which will be, say, the 1st of July in 2080. Again, we choose the 2-meter temperature, and the location will be different for this case. So for example, let's type Switzerland, and the resolution 1.0 degrees. So type that as well. And the output format is in that case a PNG file. So if we then click enter, you see the temperature, the 2-meter temperature over Switzerland, and you see the downscaled data over the Alps right here. We can also change the SSP scenario for this one. So for example, we can go back to another one, say 460, and then you see a slight change in the temperature for the date of the 1st of July in 2080. We can also expand that to other countries. Say, let's try that out for the USA and choose a coarser resolution so we don't run into any limits. And by clicking on enter, you see a visual representation of the temperature over the United States of America for the 1st of July in 2080. We can also do the same for Australia or any other country in the world by using these country shortcuts. If you would like to query something more individually, you can do that by replacing that the country name with the longitude and latitude coordinates, and over here I just selected Australia. Again, I can change the SSP scenario, say to 126, which is the one with the lowest dramatic change, or with the least dramatic change. So you can have these overview right here as well. So in that case, I think I was able to show you how you could build a query from scratch, or how you can build your own query using different climate scenarios and locations. And now I'm pretty happy to answer all your questions. Thank you for your attention. Okay, let's just head over to the last slide of the presentation so you can all see the contact details again. So again, if maybe there are some unanswered questions from today, just refer back to me or to the sales team, and I will just have a look. At the questions right now. So there's a question from Jean-Pierre. Thank you for attending. What is the pricing of this API? So the pricing pretty much depends on many factors. For example, if you say have a model selection, or if you select a whole area, how many queries per day you are using. So I would like you to direct you to the sales team, and they can help you build a solution that really fits your needs. So it's a very hard to answer that with, say, one price tag. So can you please add a nice color map in the PNG queries? So in general, these are like our default PNG default color maps. So if you are keen to obtain the data, feel free to do so, and to add the color map of your that fits your requirements as well. So for now, this is like our color map, but we are constantly working on improving even our color maps. Is it possible to have a background map on the fields? So with the PNG query, not as I'm aware of, but if you download the data, then you can display them on a map. But maybe I can also have a look at another output scheme right here. Let me just double check if that works out. Okay, there we go. So yeah, we have this HTML map output as well, and then you can take your mouse and go over there as well, and you can infer pretty much the temperature. Do you have data available for climate extreme indices? Which indices are you referring to specifically? So in general, we do provide, say, temperature, precipitation, radiation, and wind speeds, and we infer some parameters from that as well. So say you could query, say, the wind gusts, for example, over a certain time period, or even like the mean temperature over, say, 24 hours, maybe. I hope that that answers your question. Have you got a free plan for the API? So in general, you can sign up for a trial account on our API. So when you go to our getting started page right here, there's a little yellow box in the lower left corner, and it says get access to our API. So if you click on that and enter your details, you generally have a 2 weeks trial where you have, I think, even 2 years of climate data for free. Just as a follow-up question, I'm interested in the indices based on the ETC CDI using MaxTemp and PPT. Oh, okay, so yeah, at the moment, so this is something we probably look into more in the future. Right now, we pretty much have the maximum temperature, minimum temperature, and some, yeah, and the same for the precipitation right now. But yeah, we are always happy to expand on that. So we were just pretty much getting started with the whole climate API or climate data into the API. We are trying to build or to build up on that. So that's very good suggestion. Thank you for that. So thank you for the talk. Thank you, Christopher. Does this new data also represent changes in daily weather variability as well as climate local averages? That's a very good question to ask because with climate, so the native data is in a resolution of 3 hours. So you might see some local changes as well. And as we do the downscaling of the temperature, for example, you probably could identify some variability in the daily weather as well. But this is something, yeah, we would need to investigate as well. Another question. Is it able to have loops of temperature change in Europe until 2100 according to SSP1 to SSP5? With loops, do you mean, say, like a temperature curve, maybe from now to 2100? I hope I understand that correctly. So in general, what you could do with the API call, you could say, okay, I would like to query the temperature, like as I showed in the beginning, say a monthly temperature, for example, and then you make that query from now for each month until 2100. I hope that covers your question. If not, please feel free to follow up on that. Okay, this is a longer one by Nelson. Thank you, Nelson, for the question and for tuning in. We are planning a solar and wind-powered yacht experiment across the Atlantic, looking to define the best trim parameters autonomously. Could we link real-time weather information to the vessel for geodata analytics purposes? Indeed, you can. So we do like in general, like apart from the climate data, we do provide solar and wind power forecasts as well, and this could probably fit your needs. So I'm I'm not sure if you're looking to do that maybe in the future as well, or like, okay, no, hang on, you said a real time weather. Okay, yeah, so yeah, you can definitely do that. Oh, that's a tough one. How many CMIP6 general circulation models data is available? Do you have a MME data? So within the CMIP6, say consortium or framework, there's a huge amount of models and even climate scenarios available. So um, yeah, please accept my sincere apologies. I'm not aware of any number right now, but in general, it's a lot, and we chose the MRI specifically. So because we had all 5 runs, like all 5 climate scenarios available at the highest resolution possible, and that made it a bit easier for us to compare the runs as well. Okay. Yeah, thank you, Jean-Pierre and Nelson, for your answers. So they both said thank you for the talk and that they are interested. Thank you so much. Okay. So there's a follow-up one from Katja. We have seen anomalies 20 years minus 30 years, something like this as an animation until 2100. So this is a very good suggestion, and I think this is something we might implement in the future. So you can directly query anomalies from the API. And right now, at this stage, you would have to download the data and do your calculations based on that. But this is definitely something you will look into. This is a great one. My pleasure. Okay. Another question. Can you aggregate data across part of a country? Indeed, you can. So when you go to our Getting Started page, which is right here, and you scroll a bit down and have a look at the headline Get Parameters on a Grid, you can pretty much specify your own grid. So over here, this is, for example, 50, 10, 40, and 20, so which is around the Alps region as well. And if we say copy that into this query right here and we replace Australia with that, we should see, yeah, the same region. And we also, like in that case, we have tooltips which show a quick representation of the temperature. Okay. There's another question regarding the validity of the climate data. So in general, all these runs are finished already, and as you are all probably aware, there are no really observations in the future right now. So the validation pretty much comes from the fact that the MRI is part of the CMIP6 consortium and the framework. So they ensure that you can compare different scenarios with each other, different thought experiments. So this is the kind of validation. And what we do is we take the data in terms regarding the temperature, we apply a downscaling. So we don't really further process the data apart from this downscaling. Are there any other questions that are probably unanswered right now? Can't see any questions at the moment. So I think, yeah, as you are probably all within a very busy schedule, although it's Friday, I will probably close this webinar right here. So I would like to thank you all for your attention. I would like to thank you for tuning in and being interested in our weather API in general and the climate data specifically. So again, I will probably pull up the contact information again. So you have the email addresses where you can refer your questions to. So yeah, I wish you all a nice weekend, and hopefully you can enjoy the pre-Christmas time. All the best. Thank you.